Okay, I'm going to give some notes on session 10 of Math 123 since we had some technical problems. So I will get this uploaded to you and we'll go from there. One of the things I wanted to mention, to get some of these things out of the way, is we're talking about fractions tonight, and that's the main consideration. And some of that is coming up with the idea of the least common denominator. If you look at these two fractions, like 1/2 plus 1/4, not a bad place to start for the kids to work with the fractions. But as we look at that with something like this, and a student might be able to see that we really can't add those, and that's what you're trying to get across. And so if they would take this then and divide, and I'll put it in a slightly different color maybe, divide this one into 4 parts, then they could see that this particular fraction is the same thing as 2/4, and so then they go 2/4 and the 1/4 and be able to get to the 3/4. And the same concept would be over here as they look for this. So what we're concentrating on is this fact that we need a common denominator. We usually try to get the least common denominator, but a common denominator will work. And the same thing is here. The students would need to look at this, but then as they count those up, they're going to we have our 2/4 plus our 3/4, and as they can count these, the 1, 2, 3, 4, 5, so they can see they add the numerators, and it's still fourths. And then possibly when you have done this, it would be possible then to take say this one right here and move it over on top of that. Of course, I didn't do a very good job of the cut and paste thing there, but that's why I probably shouldn't have passed kindergarten. But they could see that we now have the 5/4, but that's the same as 1, same as 1 here plus a 4th, so you could get into the mixed numbers that way. So that would, whoops, so that equaled the 1 and 1/4. When they get into something like this where they have to change both, it gets a little more complicated. And one thing they can always do is they can always multiply the denominators together to get a common denominator. In this particular case, it is the least common denominator, but sometimes it might not be. So if for example, if we had 1/6 plus 1/4, if we had 1/6 plus 1/4, if you multiply the denominators together, you're going to get a common denominator of 24, even though 12 would be the least common denominator. So but it does work, and then they just have to simplify. So if they know that it's going to be 12ths, then you could look at the fact that we have 3 here, and if we put 4 here, we can get it all into 12 parts. Now these may not be the same size when I do that, and then we could go 3 here. So ideally you'd have this set up so that it was I guess I should have gotten the line thing, but so that would be the concept. But you could see that this would be 8/12, and this would be 3/12 when they counted up those little rectangles. And so that leads them to the fact that when you have 2/3, you're going to take 4 times 3 to get 12, and so you take 4 times 2 to get the 8. And again, all we're doing is multiplying by 1. So we haven't changed the value of it. It's still the same amount that's shaded, but we now have a number that we can use with this one down here, because the 3/12, or the the 1/4, if we multiply both numerator and denominator by 3, we get 3/12. And again, this is multiplying by 1, so we haven't changed anything. So that's one of the main concepts, or some of the main concepts that needed to be discussed tonight. When we
Dr. K, can you hear me?
Yes, I can. Just a minute. When you're looking at the discussion questions for section 10, you're basically looking at section 4.3, and there are several investigations. There's investigation 4.3a, using fraction models to understand addition of fractions, and then it goes on different ones, and you're just picking out one of those and to discuss and tell what you like about it or what you didn't like about it, and that's that's all the discussion is. Make sure that you respond to 2 others, because that's where you pick up the extra points. You get 6 points for your post, and then 2 for the 2 reactions to 2 other posts. So again, just look at one of those investigations, pick out one, tell what you liked about it or didn't like about it, and it shouldn't be too difficult. Hopefully it's not. So now let's look at the problems for the assignment for tonight. And this first one, number 20, was hope I've got the right one. Let me double check here. Yeah, it is. Anyway, it's talking about a method of subtraction. The method that most of us probably grew up with was this, where you got your common denominators, just like they have here, 7 and 3/12 minus 2 and 4/12. And what we would say, well, you can't take 4 from 3, so you had to borrow. So you would borrow from the 7 and make that a 6, but what you borrowed really was 12/12, because that's what 1 was. So 12/12 plus 3/12, this became 15/12. When you borrowed that 1, you borrowed 12/12, that made it 15/12. Then you take 15 minus 4 and get the 11/12. 6 minus 2 is 4. Now that's the method that I grew up on, but this particular method, when you look at it, they go ahead and start using some negative numbers. They take 7 minus 2 is 5, and 3 minus 4 is a negative 1 or negative 1/12. So they're saying it's 5 and a negative 1/12. Well, if you take 5 and subtract 1/12, you end up with 4 and 11/12. Basically, the same thing, because the 5 becomes 4 and 12/12, and you subtract 1/12, you get 4 and 11/12. And that's the process, and that's that particular algorithm. And so all you're doing there is just talking about what they're doing, and that's what they're doing. And and it probably should work. It'll work. And then compare that to the standard, and that's our standard right there. And you might even say whether you like it or dislike it, but it's kind of an interesting approach. The next problem has to do with a word problem and students' answers to these. And okay, from the ice cream factory, you order 6 pints of ice cream. If you serve 3/4 of a pint of ice cream to each guest, how many guests can be served? And you've got different ways that people will handle that. Now this person said they took 24 and divided by 3. Well, where did they get 24? They were looking at 4 times 6. 4 times 6 got them 24, and they divided by 3. Another person took 8 times 3/4 equals 6. So they got their answer of 6. There's our 6 quarts. And so they're saying the answer was 8, because you can take 8 times 3/4 and you get how many pints you have. And so they're saying the answer was 8. Now, this person just started with 3/4 and kept adding. 1, 2, 3, 4, 5, 6, 7, 8. And they kept adding, they got to the 6. And so the answer was 8. This person started with the 6 and started taking away 3/4 each time. They took it away once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and 8 times. And they were finally out of ice cream, and so they were able to serve the 8. So now, those are some ways people worked it. Somebody might work it using a drawing or some type. They may, if I can get this. Well, they might do a drawing and say they had 6 of those, and then do one or the other of those type things. They may go like that, divide everything into fourths, and probably the easiest way there would be to divide everything in fourths to start, and then copy it. And forgive my scribbling or my slanted lines, but you can get the idea. And you would have the 6 chords, and then you could fill those with, let's have chocolate ice cream. There'd be 1, and 1, 2, 3, there'd be 2, and they could just do it that way, basically kind of a combination of those. But they might use the visual part, which would kind of help. Now it would be possible, if you were doing this on a paint program like this, to change it so you can see, change the color so that you can see the 3 each time. It'd be easier maybe to count or figure out what you have. And then the final one, and you can see we'd have 8 different helpings. When you look at these next problems, student in your class says that 2/3 plus 3/5, not sure I have that in the right spot where you can see it, plus 3/5 equals 5/8. I think it's fairly obvious what their student is doing, but maybe not, because I've had people tell me that, well, this is obvious, and I'll sit there and not be able to figure it out. So okay, so if we have 2/3 plus 3/5, what they have done, of course, is add the 2 plus 3 is 5, and they've added 3 plus 5 is 8. So they aren't getting the fact that you need a common denominator between the 3 and the 5. And what you might do again is go back to that box. You might go back to the box and try to have common denominators, and figure out what you would have to do to have the common denominator. So you could, where this was 3 and this was 8, or 5, I guess it wasn't it 5, sorry. And this was 5. And again, so you like to think of those as being equal, but they aren't necessarily. And then you could just do the fill them in type of thing. So we have 2/3. I'm not going to be able to do that with what I have there because I didn't complete my drawing. But you'd have 2/3 and you'd have 3/5, and at that point then you could look at the 3 and the 5. You could look at 15, so you could divide this into 5 equal parts. Oops. And then this into 3 equal parts, and look at what you have in order to solve. And so that type of thing might help them understand it. When we look at 52, you notice the least common multiple. Oops. The least common multiple is basically our what we need to solve a lot of problems. If we were looking at 12 and 20 as fractions, that's what we would be looking at. We were looking at 1/12 plus 1/20. We would need the least common denominator, so we would need the least common multiple. So it's the same kind of concept. Now you can do multiples of 12 and 20. You can do that because you want the least one. You could get 12 times 20 will give you a common denominator, a common multiple, but maybe there's one that is lower than that, and there is, because the 60 would be our method there. The other method is kind of like we were doing the other night with the greatest common factor, and that is taking the 12 and the 20 and getting that into 2 times 6, so 6 is 2 times 3, so there are our prime factors right there. The 20 is 4 times 5, or 2 times 2 times 5, and then do the Venn diagram where we've got the Venn diagram. Now this Venn diagram, the part we have in common, remember the part that we have in common, we have a 2 and a 2, so that goes here. One of them, we have a 2 and a 2 here, so that goes here. Then the part that's not common, the 3 here and the 5 here. So what we do is take our greatest common factor of 4 and multiply times 3 times 5, and that would give us our 60. So 3 times 4 times 5. This method right here worked fine for this because it's fairly short, and that's why you might want to use just start listing the multiples. But that would also then be our least common denominator, would be the 60. When we look at B, the 30 and the 75, again you could start listing them, and 30, 60, 90, 120, 120, and 150, and I think right there you might see that 150 is because 75, 150 is next, so that's going to be that way. Again, you could do it with the Venn diagrams. 44 and 66, that might take a little more time to recognize. Not sure how far you'd have to go. So again, you could list them like this, or we can do that Venn diagram, and this time we'll do a different method. 2 times 2 times 11 gives us our 44. Our 66 is 2 times 3 times 11. And so I think you can see that our there's going to be a 2 that's common, and there's going to be an 11 that's common. If we were doing the circles, that 2 and 11 would go into the 2 and the 11 would go in the center, and out here would be the 2 and the 3. Well, 2 times 11 is 22 times 2 times 3, in the order you want to do that. So 6 times 22 would be 132. And again, you could have gotten that 44, 88, 132, and 66, 132. So this particular case, probably just the listing would have been quicker. And maybe the listing is quicker on D, but we're going to do it with the other method that I was talking about, the 462 and 630. And I don't know what way you like. We know this is even, so and what goes there? Looks like 11 does. 11 goes to that 22. Is that right? Times. So 11 times 21 would be 231. So it goes 21 times, and then this would be 3 and 7. Now you might have done it a different way, and that's fine. Those are our prime factors: 2, 3, 7, 11. Now then I think you can see that 630 is going to be, we'll do it like this: 63 times 10. This is 9 times 7 times 2 times 5. 9 is 3 times 3. So our prime factors here are 2, 3, 3, 5, and 7. And again, you can take those that are common. There's the 2, there's the 3, there's the 7. You would multiply those two together, 2 times 3 times those 3 together. That would be your inside of those circles. 2, 3, 7. So 42 would be our greatest common factor. That's the 2 times 3 times 7. And then this number would have the 11, this would have a 3 and a 5. So you would have to multiply those numbers right there together. That's a 42, not a 4 times 2. So 42 times 11 times 3 times 5 would give you your least common multiple. Now, when you start looking at 53, it's the very same process, it just takes longer because you have an extra number in there. But again, you might want to start doing the multiples like this again, because you know that some multiples of 75, like 150, then you could look to see if 12 goes into 150, because we know that 3 would go into or 30 would go into 150, because 5 times 30, so we have some others in here, but you'd eventually get to 150. And the question is, does 12 go into 150? And you could just do that. Take the 12, does it go in there evenly? And the answer is no, it doesn't. So it's going to be it's going to be on up here ways. And you could go to the 225 if you want, but it would go the 300, because at 225 we know that 30 and 12, neither one would go into that evenly. So then you could look at 300 and try to decide. But again, maybe this is a better time to do that Venn diagram approach and just look at the prime factors, because it wouldn't be too hard to get prime factors here, and the 30 and the 75. But now when you do the Venn diagram part, you're going to have 3 circles. Oops. And you will put those things that are common. Okay, none of this one doesn't have a 2, but it has a 3 and a 5 and a 5. This one has a 3. This one has a 3. This one has a 3. So 3 is the one that's in all 3 circles. Now you're going to have to basically multiply the rest, because we have, we can do some common things here. Let me put little squares around these. That's common between these two numbers, and a 5 is common between these two numbers, and nothing is common other than that one that's in all 3. Nothing's common between these. If this is 12, oops, I should have written that, 12, 30, and 75. And then any numbers that are left over, there's a 2 left over here, and on the 30 everything's been accounted for, but there's a 5 here. But check that out to see if here's 10, here's 10, here's 2 times 5 is 10, 2 times 5 is 10. So 10 times 10 is 100, times 3 is 300. So we know the 30 goes into 300. Does 12 go into 300 like we were doing up here? And it does. So you could have done it this way, just kept moving these up till you found something that all 3 would go in, or you could do it this way, and you multiply 2 times 5, which is 10. 2 times 5 is 10. 10 times 10 is 100, times 3 is 300, and that's our least common multiple. So the choice is yours on how you're going to do it. It's nice to be able to do both, and that's true for the students as well. It's nice for them to be able to do both. On 20, 30, and 40, as we look at 20, 30, and 40, I think you'll find that is maybe a little easier just to go ahead and list them. And again, what I usually do on that is start with the largest one, because I can see 30 won't go into 40, so then 20 will go into 80, but 30 won't. But now we look at 30 can go into 120, and 20 can go into 120. So 120 is our least common multiple. But that's that's what I usually do, is I start with the largest number and start listing them, and then just either glance or like I was doing on the other, do the actual math, do the actual calculations. This next one, since we're working with least common multiples, you might guess that that's what we're going to look at, because he vacuums the rugs every 18 days, mows the grass every 12 days, and pays the bills every 15 days. And what you're looking at is he did them all today. So he did all 3 today. When will be the next time that he will do all 3? So you start looking at multiples, or again you do the Venn diagram, and we will we'll look at both. And if I get to some place, if we were in class, I'd ask you to tell me when to stop. But we have to keep on going. And the problem with this is I start doing this and I get carried away, and I'll make some mistake way back, and I'll make a mistake here or whatever, and when I add on something, it doesn't work. So let's look at doing this with the prime factors, and I'll just use the tree because I like the tree. And there are my prime factors: 2, 3, 3. 12 is 2, 2, 3, and 15 is 3, 5. And now when I do my circles, the part that's common to all three, and let's just circle that, there is a 3 in all three. So that part goes here. That's our greatest common factor between all of them. But then we look at here's better again, mark what my numbers are. This is the 18, this is the 12, and this is the 15. On the 18, between the 18 and the 12, there is a common 2, and there's a 3 here, a 2 here, and the 15 has a 5 down here. Nothing in common between the 12 and the 18 other than that 3 that was in the center. So now when we multiply those together, we have 3 times 2 is 6, times 2 is 12, or maybe go this way. 2 times 5 is 10, times 3 is 30, times 2 is 60, times 2 is 180. Is that what we would have gotten to if we kept on going here? And yeah, we would have eventually this would have been 180. 12 would go into it, 15 would go into it. So it would work. 12 does go into 180 and 15 does go into 180. So those are a couple of methods that you could use to solve those. The last problem on tonight's assignment is basically the same concept. Ann completes 1 lap every 12 seconds and Bob 1 lap every 15 seconds. And so what you're looking at is when will they start out together, when will they be hitting or side by side again? So when will they lap? When will Ann lap Bob? And so you start looking at the least common multiple. And sure enough, when you get up here to 60 seconds, you'll see that, and I'm going to go ahead and put these for a reason, is because it says when will Ann lap Bob, assuming they started together. Well, she'll lap him in 4 times around. So basically 4 times 15 is going to be 60 seconds or 1 minute. Oh, Bob completes the lap. Oh, she completes it in 1 lap. Sorry about that. She completes 1 lap in 12 seconds. I goofed someplace here, didn't I? 1 lap in 12 seconds. So it's going to be so she does 5 laps in 12 seconds. He does 4 laps in 15 seconds. So I guess I didn't goof. I just looked at the problem again after I got done thinking I goofed. But so that's the process. The other thing that we were going to work on tonight, and that I just put in the module, and like I say, I'll make it make it an assignment thing, but not don't know what happened to it. But as a bonus, so if you want to try it, you can. This was bonus 7 in my little booklet thing that I have, but with all the Facebook things and all the things going on about the NFL, I thought this is an appropriate time to do this. We won't have the Star Spangled Banner or anything, so you don't have to worry about whether to stand or kneel. But what you do is you try to figure out, based on the clues, who was wearing what jersey, what was who arrived first, second, third, and fourth, what were their names, first name and last name, and what jersey did that person wear. And those are the clues that you would have. I put it as a file in the module on session 10 module. So it's and if for some reason I don't get this, if I don't get this set up for you to turn it in, you can just email it to me or whatever. But this is in the session 10 module. You will see that file, and it's just it's bonus. It's a bonus, a 10-point bonus, I guess. 10 points if you get it all right, 5 if you get most of it right. Okay. But let me show you where that is for sure. If you go to modules, this is what will come up, and there's your assignment, your discussion, and there's that problem. Right now it's sitting there as a JPEG, which doesn't allow you to work on it, but so I need to I'll redo that and try to get it as just as a Word document or as a document that you can upload as an assignment. But I'll do that as soon as I finish this part. But that's not a requirement, but it's there if you want some extra points. Then the last thing I wanted to bring up is just a reminder to check your grades to see if you didn't get the points you thought you should have on something such as a project. So check those grades. And for example, on project 1, if you didn't get the grade that you thought you should get, and you should have been up in the somewhere in to the 90 to the 100, or if you turned it in early, a little bit more than that. But most likely what's happened, because it's happened for 2 or 3 people, is when you uploaded something, I got say a document here and another document here, and in a couple cases when you uploaded the same document, just made a mistake. So one is the answers to the questions based on that the videos that you watched on that teacher, and then the other is the UBD design. And yes, the UBD plan, just stage 1. Stage 1 is redundant. There's a lot of things that's kind of overkill on it. It seems like you're answering the same question, just a slightly different form. But that's what you're looking at. You're doing stage 1. When you finish that, go ahead and turn that in if you haven't already. But then project 2, you can do a whole new UBD design, starting from scratch. Make sure that you list the core, the core numbers and what they state there when they're talking about it in stage 1. So you can do the whole new thing, or continue on with that first one, continue on with project 1, and just add stage 2 and 3. And again, there's a sample in the assignments, a sample in the modules for that. So hopefully that'll help. And next session we'll try to go over any questions you have on the quiz. If you bombed out on something on the quiz, I can allow you to do some stuff again, maybe give you some slightly different problems or whatever. But just again, don't forget on the discussions, you make your post and then you respond to 2 others. Okay, so the end. I'll see if I can get this posted.